All right, today we're going to talk about something that I'm pretty sure is a source of universal pain. It's a ghost from pretty much all of our school days and a huge challenge for kids right now, the math word problem. You know the feeling, right? You're staring at this block of text and you can just feel your brain starting to fizzle out. But why? Why are they so ridiculously hard? Let's get into it.
Oh, man. The dreaded train problem. It's a classic for a reason, isn't it? It just instantly gives you that feeling of dread. Because it's not just a math problem. It's a reading comprehension test, it's a logic puzzle, and it's a math equation all smashed into one confusing package. So really, why is this specific format such a massive headache for so many of us?
Okay, so first up, let's try to unpack this thing. Let's look at the word problem as a puzzle that researchers are actually trying to solve. And this is so important to hear right off the bat. If you find these hard, it's not because you're bad at math. The science is really clear on this. Solving these things is an incredibly demanding job for your brain. I mean, think about it. You have to read the words, understand the situation, build a little movie of it in your head, figure out which numbers actually matter, pick the right kind of math, and then finally do the calculation. That's a ton of mental juggling, especially for a kid's brain.
So how do we crack this code?
Well, a team of researchers decided to go all in to find the real reasons. Let's dive into what they did.
And this was no small-time experiment. The researchers performed what's called a meta-analysis. They gathered up the results from 69, that's right, 69 different studies. All told, that's data from over 17,000 elementary school students. So we're getting a huge, crystal-clear picture here.
So what is a meta-analysis exactly?
Well, here's a good way to think about it. If a single study is like taking one picture, a meta-analysis is like taking all of those pictures, layering them on top of each other, and creating one super sharp, high-resolution image. It lets you see past all the random noise and find the one true signal of what's really going on. And just so we're all on the same page, this is the official definition of a word problem we're working with today. Seems simple enough, right? A verbal description, apply some math, get an answer. But as we are about to see, the devil is 100% in the details. All right, so here's the big reveal. What did this giant study actually find? Let's look at the absolute biggest stumbling blocks that trip kids up.
Now this is fascinating. The single biggest thing that made word problems harder for kids, it wasn't the complexity of the math. It was whether the problem forced them to stop and apply some real-world common-sense logic.
The researchers themselves put it really clearly. So, for example, imagine a problem that asks how many buses you need for 110 kids if each bus holds 30. Now, the pure math answer is 3.66, but you can't have 0.66 of a bus, right? In reality, you need 4 buses. That extra little step that, hang on, what makes sense in the real-world moment, turned out to be a major hurdle.
And this chart just drives that point home. It shows you just how massive that factor is. A bigger bar means more difficulty. And look at the bar for realistic considerations. It's not just bigger, it's enormous. It's more than 4 times larger than other big challenges. It doesn't just beat the others, it completely dwarfs them.
Okay, so what's the second biggest issue? It's something called lexical inconsistency. Basically, it's when the words trick you. We often teach kids to look for keywords, right? Altogether means you should add. In that first example, it works perfectly. But look at the second one. The word altogether is still there, but to actually solve it, you have to do subtraction first. It's a total keyword trap, and it shows just how badly that strategy can fail.
And here is the third biggie. It's all about where you put the question mark. See, for most kids, the equal sign just means put the answer here. So when you flip the script and ask them something like question mark plus 5 equals 7, it kind of breaks their mental model. It forces them to think about what equals really means, that it's about balance, and that is a huge cognitive leap. So we know what makes these problems hard, but what's almost more interesting is finding out what doesn't really matter. The data had a few surprises up its sleeve.
So here's a common piece of advice we've all probably heard. Make the problem about puppies or their favorite superhero. Use their name. It sounds so logical, right? It should make it more engaging and easier. But what does this massive analysis of 69 studies actually say about that? Well, the answer is it doesn't really seem to help. Across all those thousands of students, the researchers found no consistent, reliable proof that personalizing a problem makes kids any better at solving it. It's just not the magic bullet we all thought it might be.
And here's another one. We tend to just assume that, of course, multiplication problems are going to be harder than addition problems.
But the data showed that's not really true across the board. The crucial point is that those other factors we talked about, like real-world logic, are way, way more important for predicting how hard a problem will be than just what kind of math is involved.
Okay, so we have this really clear picture of what makes word problems hard and what doesn't. So the huge question is, what do we do about it? Let's look at how we can actually make math make sense. The research points to 3 key takeaways. First, we need to teach what the equal sign really means, that it's a balanced scale, that both sides are the same. This directly attacks that unknown at the beginning problem. Second, we gotta ditch the keyword tricks. Instead, we should teach kids to recognize the underlying type of problem. Is this a change problem, a comparison problem? This gives them an actual mental toolkit. And third, be smart about the order you teach things. Start with the simple stuff, one step, unknown at the end. And only after they've got that down, you start building up to the more complex structures we know are tough.
And that really leaves us with one final, very important question to think about. This research gives us an incredibly clear blueprint. It tells us that what really matters is focusing on real-world context and flexible thinking, not just memorizing keywords. So the question is, does the way we currently teach math actually reflect what the science is telling us? It's definitely something to chew on. Thanks for digging into this with me.